Where did everything come from? Not just the Earth or the Sun or the stars, but everything. All the matter, all the energy, all of space, and even time itself. It is the oldest and largest question there is. And astonishingly, we have traced the answer back to a single instant, 13.8 billion years ago. The story begins with a discovery. When we look at distant galaxies, we find that almost all of them are moving away from us. And the farther away they are, the faster they flee. The astronomer Edwin Hubble first measured this pattern in the 1920s, and it changed everything. By carefully clocking how fast galaxies are receding, we can rewind the whole expansion and calculate exactly when it must have started. The answer comes out to 13.8 billion years ago. This means the universe is expanding. Every galaxy is rushing away from every other, like dots on the surface of a balloon being blown up. And that leads to an unavoidable question. If everything is flying apart today, then in the past, it must have been closer together. So what happens if we run the film of the universe in reverse? Rewind, and the galaxies rush back together. The universe grows smaller, hotter, and denser. Keep rewinding, past the first stars, past the first atoms, until everything that exists is squeezed into a space smaller than a single grain of sand. The conditions there are almost beyond words. Temperatures of trillions upon trillions of degrees. Densities that make a neutron star look empty. All the mass and energy of 2 trillion galaxies packed into a volume smaller than an atom. And at the very beginning of that rewind, 13.8 billion years ago, we reach a moment where the entire universe was compressed into a single, unimaginably hot and dense point. We call the moment it began to expand the Big Bang. But let us clear up the biggest misconception right away. The Big Bang was not an explosion in space. There was no space yet for it to explode into. It was the explosive expansion of space itself, everywhere, all at once. Every point in the universe today was, in that first instant, in the exact same place. The Big Bang did not happen at a location. It happened everywhere, including the very spot where you are sitting right now. Now let us play the story forward and watch the universe create itself, second by second. What happened next is the most extraordinary sequence of events imaginable. In the first tiny fraction of a second, the universe did something almost impossible to believe. It ballooned. In an event called inflation, space expanded faster than the speed of light, growing from smaller than an atom to larger than a galaxy, in less time than it takes to blink. This was not matter moving through space, it was space itself unfurling. Inflation smoothed the young universe out and stretched tiny quantum ripples into the seeds that would one day become galaxies. In these first instants, the 4 fundamental forces that govern all of reality, gravity, electromagnetism, and the 2 nuclear forces were still fused into one. As the universe cooled, they split apart, one by one, setting the very rules that everything to come would have to obey. At this point, the universe was a searing hot soup of pure energy, far too hot for anything solid to exist. But as it expanded, it cooled, and out of that raw energy, the first particles of matter began to freeze into being. And here we run into one of the deepest mysteries in all of science. Matter and antimatter should have been created in perfectly equal amounts and destroyed each other completely, leaving a universe of nothing but light. But they were not quite equal. For every billion particles of antimatter, there were 1,000,000,001 particles of matter. That tiny 1 in a billion imbalance is the reason anything exists at all. You are made of the leftovers. After the first 3 minutes, The universe had cooled enough for the simplest atomic nuclei to form. Hydrogen and helium, the first and lightest elements, the raw material from which every star would one day be built. But the universe was still far too hot and chaotic for light to travel freely. For the next 380,000 years, the cosmos was an opaque, glowing fog. If you had been there, you could not have seen your own hand. We did not go looking for the echo of this fog. We stumbled upon it. In 1965, two engineers found a faint, annoying hiss in their radio antenna that they could not get rid of. It was coming from every direction in the sky. They had accidentally discovered the afterglow of the Big Bang itself. Then, at last, the universe cooled below a critical temperature. Electrons joined with nuclei to form the first complete atoms. And suddenly, for the first time, the fog cleared and light was set free to travel across the cosmos. That very first light is still traveling today. It has been stretched by billions of years of expansion into a faint glow of microwaves filling the entire sky. We call it the cosmic microwave background. It is a baby photograph of the universe. When we map that ancient light, we see tiny variations in temperature, the fingerprints of those quantum ripples from inflation. Those faint patches are the seeds of everything. Every galaxy grew from them. But after the fog cleared, the universe entered a long, dark, and lonely age. There were no stars yet, no light sources at all, just vast, cooling clouds of hydrogen drifting in total blackness. Astronomers call it the cosmic dark ages. Slowly, over millions of years, gravity did its patient work. It pulled those clouds of hydrogen together, denser and denser, hotter and hotter, until deep inside one of them, a spark of nuclear fusion finally ignited. And the very first star switched on. After 100 million years of darkness, the universe had its first light. And it was spectacular. The fierce radiation from these first stars flooded back out into the darkness and slowly burned away the last of the cosmic fog in an era we call reionization. The lights of the universe were, one by one, switching on for good. These first stars were monsters, hundreds of times more massive than our sun. They burned furiously, died young in brilliant supernovae, and in their deaths forged the first heavier elements. Carbon, oxygen, iron, the stuff of planets and of life. Gravity gathered these first stars into the first small galaxies, and those galaxies merged and grew into the great spirals and giants we see today. Structure blossomed across the cosmos on every scale, but galaxies could not have formed so quickly on their own. They needed a hidden scaffolding. An invisible substance called dark matter, which outweighs ordinary matter 5-to-1, provided the gravitational framework on which all the visible structure was built. Our own James Webb Space Telescope is, right now, capturing the light of these very first galaxies, seeing them as they were more than 13 billion years ago. We are, quite literally, watching the universe grow up. And there is a final twist to the story. Around 6 billion years ago, a mysterious force called dark energy began to take over, and the expansion of the universe, which had been slowing, started speeding up again. The same force that began in the Big Bang is now driving the cosmos apart, faster and faster. Billions of years later, in one ordinary spiral galaxy, a cloud of gas and stardust collapsed to form a modest yellow star and a small blue planet. And on that planet, atoms forged in the Big Bang and in dying stars arranged themselves into something that could look back and wonder how it all began. Which brings us to the two questions everyone truly wants answered. What came before the Big Bang? And what caused it? The honest answer to the first is strange. According to our best theories, time itself began with the Big Bang. Asking what came before is a little like asking what is north of the North Pole. The question may simply have no meaning. And what caused it? Here, science reaches the edge of what it currently knows. There are ideas. Perhaps our universe bloomed from a random quantum fluctuation. Perhaps it is one of countless universes in a vast multiverse. Perhaps our universe was born from inside a black hole in another universe. Or perhaps it is part of an endless cycle, expanding and collapsing and being born again forever. For now, these remain some of the greatest unanswered questions in all of human thought. And perhaps that is exactly as it should be. A universe that handed us all its secrets at once would leave us nothing to reach for. The mystery of the beginning is not a failure. It is an invitation. But here is what we do know, and it is remarkable enough. We know the universe had a beginning. We know its age. We have found the baby photograph of the cosmos and traced our own atoms back to the first 3 minutes of time. A species of curious apes, on a single small world, has looked back across 13.8 billion years and reconstructed the birth of everything. That may be the most astonishing story of all. The universe began, and somehow it produced something that could understand it, keep wondering, and get spaced out.